Hello everybody, thank you for coming here, and keep in mind that Shulk's talk is very good next door, so if you feel bored or something, you can leave, but I'll try to be easy, and there is not much code in this presentation. It's more about what I have done and the problems and the solutions we experienced while implementing Gradle into different organizations. Oops, I forgot. My name is Dimitar, and I'm working for SMBC Nikko Securities as software developer. My team is in charge of the next generation of the company's proprietary trading software. I'm living in Tokyo. So this is a presentation I wish I had heard like 3 years ago. It would have helped me, and hopefully it may help somebody else now. So it is about, it's about many things, but it's also about cats. So the story starts like 2012, Christmas time, and in banks Christmas time is really downtime, you don't do anything. So that's the time when you can stop and you can learn something new. And we decided to learn Gradle, and we did a small proof of concept and we implemented it, and here are the details. So it starts at a top 10 international investment bank, equities front office. Equities front office is characterized with applications have low latency, so basically you have latency requirements, short opportunity windows, no tolerance for error, and so on and so forth. And in particular, one thing which is different from startups and other companies, that you have not only a regulatory and monetary, but also reputational damage. And the reputational damage is somebody knows that you messed up, and they're not going to trade with you. And they may not trade with you for months because they know that you're the guy that messes up. And that's only compounded because we are in Japan. In Japan, they have very high expectation of service, so basically you don't mess up. You spend the money you need, but you don't mess up. You may not offer the service, that's okay. Offering the service and not delivering is not okay. And as usually, it's a very dynamic environment, which means that what was true yesterday may not be true today. People may have said that they want something, but they may not want it today, or they may want something different. Our team was relatively small. It changed over time, but yeah, it's 6 to 10 developers. We were not in the same office, but say half the team was in Tokyo all the time, and we were in the same time zone, plus minus 2 hours. We were working together, and most of the people were fairly senior. We didn't put junior people alone in particular, we were very much against that. And people were working on mini projects, so there was not much pair programming and stuff. We asked each other's advice when we need it. Sometimes we will do a code review, sometimes we will do like the whole team code review, like everybody should be aware of this. But usually people just deliver features and integrate when needed. And yeah, there was code owners, so you may work on somebody else's code and then they would review it. But overall, we're a very autonomous team. The challenge. So our build system was bulky and complex. Pretty much that's everybody's challenge if you're attending this conference. We're doing code generation. We could have gone down without it, but overall, that's not a bad thing. By the way, the icons here, green means good, brown means bad. Release automation. The release automation, it really shouldn't have been in the build system, and that caused a number of problems. Like basically, you need to change it every once in a while and whatever. Custom packaging, don't invent your own packaging if you can avoid it. We could have avoided it, but it was there for historical reasons. And lots of scaffolding. So it was Ant, and this means that to add one project, you need to modify like 5 lists and copy-paste like a snippet of 10 targets, and then modify a little bit here and there. So it was really a lot of boilerplate. Then we used Ivy. And Ivy overall is a capable dependency management system, but the problem was that we didn't have experience with it, and the people that were tasked with it, the only thing they knew is that they want to be different from Ant. And that led to a lot of problems down the road. You can read some of the things here, I'm not going to repeat them. So overall, the things were getting out of hand. We wanted something better, and especially we want a new start. Even if we started with Ivy and Maven, Ivy and Ant, that probably would have been better, but we decided we wanted something different. So we had an opportunity, and that was a new project. So new projects in big companies start fairly, it's a rare event. Happens once in a few years. So in this case, this new project was getting approved, it was getting budgeted, like people were being allocated, also especially on the business side. So we had some time. And we didn't have any budget for tooling, but we had some development time. So we started looking at various things. And actually we looked at Gradle, we looked at Leiningen, we looked at SBT, and most of the tools were fairly specific to their domain. We also had experience with Maven before that, so we ruled it out from the start. And we decided, okay, let's give Gradle a try. And yeah, there were some risks. So downtime for the whole team is something very bad, not so much for the lost productivity, but it's again reputational damage within the company. The team cannot deliver. And we didn't want to be locked in experimental technology, especially if it's branded experimental. If it works for us, that's still not good, because in general, companies like mature products. So the image of the product being mature was very important. And there were company standards. The company standards are standards not because they're very good. They're standards because everybody can comply with them and people can work together, and also they would last through the years. So that was also very important. And yeah, we would like to be able to be independent. So the tool set was on the right, and it was a bit too much. So after adopting Gradle, it became like this. So we got rid of Ant+Ivy. For some reason, we got rid of Eclipse. All the Eclipse people, while trying Gradle, and especially Groovy, they migrated to IntelliJ. And we got rid of some scripting languages which we used in our environment, but overall it was good. As any big company, there were already continuous delivery pipelines, more than one, and we had to comply with all of them. In a way, at least we had to have an answer. So the first one was the official build system. So it was basically providing it was using the notion of golden image, which is basically a managed file system. It was a read-only file system that was mounted pretty much everywhere. And there were versions for production, UAT, QA, and there was a backend which was managing which artifacts are available where, and clean builds, of course, and the dependencies were supposed to be sourced from the golden copy. It didn't work with Maven because Maven sources dependencies from the internet. But they didn't care, and they let some Maven builds in, and we wanted one in as well, just as Maven. And yeah, we were given a green light, but we were said that we had to comply. And we said we can't comply. Then there was a special team, in a special location, a special project that we invented their special thing. So they pioneered the microservices. They went a little bit overboard with the number. And they had some custom release management tool on top of Glue. I don't know if anybody has heard about Glue, but it's something coming out of LinkedIn. I think that it disappeared by now. And they were handling their artifact lifecycle and deployment in different environments using Nexus Pro for repository. But they showed us a lot of things, like they have thought about procurement process while we were just copying artifacts and uploading them manually at that time. And being in the headquarters, they were pitching to be the next company-wide official integration solution. And then there was a mongrel of everything, build server, artifact repository, whatever. It was built long time ago, and it was not maintained, but it was used in our group, like extended team, you can say. It was based on Ant, basically. So you had to have an Ant script without arguments for any task you may want to do. Outputs go in specific location, and it had no API, no way to integrate, but we had to basically be able to run our build in it. So these were the three systems which were our environment. And we wanted to check out Gradle. So next slide. I broke down our adoption into 5 steps. So initially we thought, okay, Gradle appears to have good anti-interoperability story. So how about that? This is our build actually. Not the real build, but it was something like that. I cannot show real code. So here, this thing. Okay, so this is the build file, and this is the build template. So all these files, you have to kind of understand them if you want to change anything. Then this is how we imported it into Gradle, this ant import build blah blah. So it was short and sweet. It actually ran the build. It was working. But then the problem is that you're still depending on the whole mess of XML. If you want to change anything, you have to edit the XML, you have to understand it, and you have to understand not only the ant part, but also the Gradle part this time. We tried to use it on the periphery. Like, for example, here is a lifecycle task, and the lifecycle task depends on 2 ant tasks and has some complex enabled property, which depends on an ant property, and we're doing something fancy like going to a file and checking some condition within the file. It kind of worked. It was scary though. It was scary because the ant build was complex enough, and now you're adding Gradle, which adds a whole other level of complexity. We wanted to know how to read these builds, how to understand what's going on with the builds. And yeah, we tried also this. So this is basically replacing one of our ant tasks with Gradle, with pre and post kind of hooks. And it also worked. it would have been okay if we didn't have to use the whole Ant thing. So we wanted to learn how to read the Gradle build outputs. We realized that the Gradle log levels were actually pretty useful. So you can use the quiet log level to see what goes to the std out. So if you have print line somewhere in your tasks or even in the build, you can debug quickly with print line. It goes to the quiet level. So with quiet, you just see the print line. Lifecycle is the default, so nobody uses lifecycle. But then you have info. Info is really the verbose mode, and you have debug. The debug really is not readable. You just pipe it to a file and then grab it and slice it and dice it. Another thing, we were wondering whether we can get some more information about in general, how our build works. And the magic command here is profile. With profile, you can see breakdown of everything. But profile dry run turns out to be very useful, because with dry run, you can see whether you're doing any heavy work during the configuration phase, which you shouldn't do. So we learned about that quite late, and it turned out that in a number of places where we were having custom tasks, we had forgotten the little shift left sign, which means that everything which you wanted to do during the build was done every time during the initialization, which was bad. And then other useful options are the stack trace options, and especially the full stack trace is something which was kind of interesting, because we were kind of anxious about erasing stack frames. Now nobody uses it anymore. Continue is interesting, because sometimes when you have especially many builds and they fail, you want to just go home, and in the morning you want to see what failed. So you just run it with continue. Stop is useful if you're using some library which has static dependence, like static variables, and you corrupt the daemon, and these things happen. So with stop, you kill the daemon and you get a fresh one. Next thing is, we realized that this thing with Ant is not a good idea. So we decided, okay, we are dropping Ant, but we can still reuse the Ivy descriptors, because there is some plugin ivy.xml. That seemed like a very smart idea, because we had like 30 projects, and writing like 30 things in the Gradle dependency notation was a big waste of time if we have it in Ivy. And then we got this build. So in this build, you can see here that we have a number of Ivy patterns, like 3 of them. That's because the repository was messy. Different projects were using different publishing like paths, and over time some got deprecated, but then we still dependent on some versions, and so on and so forth. We also customized the source directories, and that was about it. Then we started like implementing small things here and there, writing mainly Groovy in the main build. And at some point now we realized that this Ivy thing is not working very well. Very often we would need to depend directly on jars, because the dependency resolution would mess up, especially with strange inheritance rules. We also were not getting our documentation and sources, because we were using some custom classifiers. So we decided, okay, we bite the bullet, we switch to Maven descriptors. We switched to Maven descriptors, and we also implemented the build in a very peculiar way. So you can see here. First, it was a multi-project by this time. And here we're doing some automation. This automation, basically, it scans a directory called projects. And for every subdirectory of directory projects, creating a project automatically, guessing the names. So you just have to add your project, and you don't have to edit any lists, you don't have to add any snippets. So we really like that. And it turned out to be a horrible idea. Somebody would create a directory just temporarily, just to put something there, and then it would try to build it. So it's not really a big deal to list your projects. It's just one place. The other thing is that, as I said, all our projects were under this projects directory, and we copied that from the actual Gradle repository, but that sounds like it was not very useful, really. It's just adding another kink to the build. If it was really that useful, it would have been the default, I would say. Then another thing which we did is we put all the dependencies in a separate file, like the dependencies for everywhere. The reason for that is that we didn't want to have a Gradle file in each project. Has anybody read the recursive make considered harmful? Yeah, it is harmful. And recursive Ant is even more harmful. But the thing is that we thought that we were going to do recursive Gradle, and that's also would be harmful. You don't want to put build logic into these files, but we'll see later that it can be done in a good way. So we had all the dependencies in one big file, and then in the main, and then we did something funny. We decided this dependencies thing, there is a lot of repetition really. So you can see that everywhere we have project name, then description, then dependencies, and closure within closure. Can we simplify it? So we simplified it. We did some DSL-ish kind of closures added as a project properties. So you can have library, then the project name, then the project description, and then you just list the dependencies in the closure. It is more concise. The downside is that nobody outside of your team knows it. No tooling can ever support it, and it was not worth it really. So next thing we did was we broke down the big build file into script plugins. That's fairly standard practice. What is not standard is that in these plugins we actually put a lot of these closures assigned as project properties, and we use them all over the place because we couldn't define tasks there. So we were having these closures, and then we would use the closures as do last and do first in the tasks. And then we had this. This is actually interesting. So as I said, we were scanning the project's directory, and we were declaring the project as basically we're auto including the project. For each project, though, we would scan the directories underneath, and if it has Groovy sources, we would apply the Groovy plugins. If it doesn't, we would apply Java plugins automatically. If it has test sources, because some projects did have tests, some projects didn't, then we would apply the test plugin. And if it has, for example, schema directory, we would apply the JAX-B plugin. The problem with that is that you never know what's going on. So often something wouldn't work, and we would go to info level just to see what is applied, and then of course you have to dump it to a file, and you have to check it, and it's really not worth it. Being explicit is much better. And this thing is actually interesting. Here we apply a plugin only if an environment variable is set. This is for release really. That's a very sensible approach, even though these days what I would do is I would always apply the release plugin, and I would disable the tasks if the variable is not set. This way you know that the things are there, and if you try to configure it, you're not going to get no pointer exception. It's a small thing, but it may make sense if the plugin is very heavy, even though you shouldn't have heavy to apply plugins. So then this thing got bigger and complex. As I said, we assigned many things as project properties like closures, and we couldn't debug them, and they were doing stuff. So we were doing like print line and quiet just to see what's going on. And then we learned about build source. So build source really, build source is a directory, probably most of you already know. Anyway, build source is a directory you can put under your project, and you can put inside any Groovy code or Java code, and it becomes available in your build. So in this case, we have a very small build here, and it uses build convention enrich project. And this is the build convention, and it has the enrich project, and then it goes here. As you noticed, it's almost a plugin, but by that time, a plugin sounded big and scary, so we wrote our own version of the plugins. Then, in the next step, we're doing auto-detect project, and this auto-detect is really calling project extension property, and then you have the auto-detector. From the auto-detector class, we lift the static auto-detector method as a closure, and so on. It's really very backwards, but it was a step in the right direction. Also, what we did here is that we broke down the big dependency file, and still using our funky DSL, we had it under each project, like here and here. So the dependencies were now living with the projects, and that's really something we are doing even now. Dependencies should live with their projects and descriptions and so on. What is project specific should live with the project. What is common should live at the top. And then we realized that we can debug our builds. You debug your builds like this. This is a magic command. And you can set breakpoints in anything under build source. You can set breakpoints in plugins. You can set breakpoints in Gradle code. You cannot set breakpoints in scripts, which means in your build scripts and your init scripts and so on. I hear that's something that is going to change with Kotlin, but right now that's the way it is. And finally, we arrived at our fifth step, the custom plugins. So this over there on the screen is a typical snippet from a build code. And to make it a plugin, you just get it, you copy paste it like this, and then you add in front of it and behind it these snippets, and that's a plugin. If you put it in build source, you can compile it binary. You can even give it a properties file, package it properly, and move it somewhere. You can publish it to GitHub, and somebody will download it and apply it. So that's what a plugin is. Now, of course, this plugin in particular is using the DSL entirely. It's very dynamic, which means that if you want to debug it, you may want to get closer to the API level rather than the DSL level. But there is nothing wrong with copy-pasting snippets. After all, that's how the script plugins work. Only you don't see how they apply this at the front and back because they use it with a script-based class. When we refactor these two plugins, then the differences are, you can see here we apply the ACM build and Acme build plugin, and there is a properties file with the name of the plugin, which mentions the class of the plugin, and here is the class under build source. And then we also replaced our custom DSL with plugins. So now we use the dependency, the description as description. We use the dependencies as dependencies, so it's the proper Gradle DSL. You can look it up on the documentation. And we apply a plugin per artifact type. And then if we have some custom configuration which you want to use, we do use extension. And that's the right way. These are the proper Gradle dependencies to express these things. And that's an interesting slide. So here I draw a diagram about maintainability versus initial effort. Vertical is how maintainable it is. Horizontal is how much effort it takes to get there. And scalability is, would it break if the build grows bigger? So as you can see, the do last closures on empty tasks is very maintainable actually. You can see it right where it is. You can change it immediately. It works immediately. You don't have to publish anything. It's very immediate. But then when you get too many of them, your build becomes quite difficult to see what's going on. It's still very immediate. The errors are pointing directly where they are. And also, you would get some duplication. You would want to organize it. You won't have functions, which leads to project scope closures. And you can have closures as project extended properties, and then you can use them in your tasks and so on. But then you're building completely parallel level of abstractions to the one that Gradle provides you. So what is better is to move directly to build source plugins if it's anything imperative, or to script plugins if it's something declarative. If you're configuring something, then you don't need to do a build source plugin. You can go with script plugin, unless you want to avoid the compilation time. But usually that's what we do. Imperative stuff goes in build source, because we can debug it as well. Declarative stuff goes as script plugin. And at some point, though, you want to share across projects. That's the time when you get your plugin out of build source, and you publish it separately as a separate project. So you can evolve these things, and that's one of the major strengths of Gradle, that you don't have to write plugins from the very beginning. It's not plugins or nothing. It's not plugins or unscripting inline. It's more like you can start small and then grow it as you need. So looking back, we start with embedding Ant, then we did a dual build as migration step, then we did the stupid build that we didn't understand what we were doing, but then with the time we learned about build source. That was a major breakthrough, so we can debug stuff. And finally, we learned how to use properly the Gradle abstractions. And it was very useful. And if we see at the incumbents, the golden source repository, they wanted us to build from version control root and tag, and that's what we wanted to, so we were doing that. They said all depends shall come from the golden copy, and that's good. We could have done it with a file-based repository, and we could have done like local modules to express dependencies and so on, but we didn't. We said that we're going to do what Maven does, and we did what Maven does, nothing. So we just went through. Then about the London-based, glue-based system. So we published to their Nexus Pro. We used their very cutting-edge release management tool. Management was very happy because they can find synergies between completely unrelated teams, reuse across the enterprise, all these good words, we're saving money. And yep, that was a big success. And for the other one, which was based on Ant, we just created an Ant script which kicks Gradle, and the Ant script after that would copy the artifacts where they need to be. And we didn't look back really, we just put it there and it was working, and that was the end of the story. So I spent like maybe 2 years on these projects and 5 years in the company, but then I got an offer I couldn't refuse. So I moved on to my current position. In my current position, we started completely new project. It's actually, let's go here. It's a top 3 domestic investment bank. It's the headquarters. And they're just as conservative as any other bank. Well, their infrastructure is mostly legacy, and they're heavily dependent on external parties because they achieved what every bank is trying to do. They unbundled their IT, which means that they fired all their IT people and they moved into a separate, fully owned company. And then they developed like objectives on their own. They want to be profitable and everything else. So now they don't have any capabilities to change internally, and they're bringing back like mini IT department. Our task is to reinvent the trading technology stack, and that includes pretty much everything. Because we have very few people, we are using extensively vendors, so anything which is kind of platform and generic goes to a vendor. Some vendors, they implement the existing technology, some vendors build stuff for us. Most of the time we have a scroll, and we have 4 people. We do mostly business logic, integration, DevOps, and what we call adversarial testing. We try to break stuff. Basically, we try to break stuff and expose problems early. So here are 3 tips for dealing with outsourced code base, especially when you have escrow. We always mirror the stuff, and we always build everything internally from the mirrored repository, and we depend only on what we build ourselves. We want to be sure that if things go sour and we go our separate ways, we actually control everything that we own, and we can continue without the vendor. That's really the #1 requirement. And there are a few more requirements from compliance. They wanted us to have some rules about who can procure new artifacts from the internet, and these rules are not so much to restrict us, but more like if somebody comes with an audit, they need to tell them, these are the rules, check them. And also release builds must be repeatable. That's actually SOX requirement. And I had a full slide about compliance, but it's gone. Too much. So going to our setup. Another listicle. So 5 build environment commandments. So we wanted to version everything. Basically, we wanted to make sure that if we check out the code base, we would get the exactly same environment, and we will be able to build this. We also wanted to make sure that we use only our repository, and we don't have special hosts where you have to build something. No special configurations on the host, no special repositories. Everything is centrally managed. And also, hosts should not be hard-coded in the checked-in code, at least not in the application code. They can be hard-coded in the environment in the end, but ideally they should be overridable. We also decided that the environment setup should not define any imperative build steps. That means that it's only a convention. You have to request from your build that imperative build step is executed, and then it will be auto-defaulted for you. And that leads to the last commandment. If you don't over-customize, things should just work. So if people over-customize, that's at their own peril. They should know what they're doing. But the people that just use the defaults, they should get like a good functionality out of the box. This is what the build looks like in our case. So we have description, we have a group. By the way, if the description is missing, the build would fail. If the group doesn't start with a company group, it would fail. We apply our standard build, and the standard build actually, it applies imperative steps, because that's what defines the standard Java build in this case. We also apply Groovy. Actually, this is still declarative. Groovy does the imperative stuff. Then we force that Groovy should be specific version. And if you force it for this group, then our plugin would guarantee that everything which starts with org code house Groovy, it is the same version. So we do the compatibility thing internally. And then we create a publication. The main publication, which is what 99% of the projects use, is easy. You just use the extension like publish main, and it creates the publication, and then it's published automatically. And then we have the dependency in the standard Gradle DSL. Most of the builds do that. Some of the builds do more, but again, we've encapsulated this as plugins. So how do we achieve this? We have Gradle, we're using Gradle user home. And all the magic is there. We decided not to modify the Gradle distribution. Instead, we have a provisioning step, and this provisioning step provisions Gradle properties. By the way, it's implemented as a Gradle script. And this is our Gradle properties. It puts some proxies. As an init version, we would see it in a second, what does it do, but the init version is usually latest version. And then the username and the repo password, these are like in pointy brackets, which means template. And what our deployment script does, it looks for these templates and it displays the text which is in the pointy brackets, and it replaces it with the user input. So that's a very lightweight customization mechanism. And we have some default stuff like the repositories and passwords and this and that. So when we get the Gradle properties, we also apply the bootstrap init.gradle. It's again very small script and very small font as well. So it has init-script. Init-script is pretty much like build-script, but it's in an init file. And we hard code here the repository because we don't have any properties loaded yet. And then we load the properties. We could have loaded the properties earlier, really. And then within the dependency sections, we load the properties in the way that usually Gradle loads them. So we start with Gradle home dir, then user home dir, then the current directory, and we roll up all these properties. That should have been done by Gradle itself, but it's not. And we get one property file. From this property file, we get this very special AC init version, which defaults to latest, but actually each real project puts it in the checked-in code. So that's what controls your environment. So we get the version which we are supposed to use, and then we apply to the class path our build bootstrap plugin with this version. So your project would, when you check it in the project's Gradle.properties, you would have this SM version. You can override it on the command line if you feel like it and test the next version or go to the previous version. So that's how the environment is versioned. And then from this jar, from this class path item, we apply the init-script plugin. This means that the init-script plugin actually is it's actually published in the repository, and this bootstrap script doesn't change. It always stays the same. We have changed it last like 9 months ago, and we've been working on this for a year. So the init-script sets up default properties, so we use property cascades. So it starts with username and password, but then you have repository username and password, which defaults to username, and then repository deployment username and password, and they're used in the appropriate locations. But if you just define your password, that's enough, because the username defaults to your system username. So you don't have to put all of them, but if you want to override some of them, you can use it. Then another thing we do is we suppress the foreign repositories. So this is a little like second order function. So it returns a function which looks at the repositories whether they start with our URL, and if they don't start, then it removes them. And we use them in the build-src repositories and in the project repositories. So if we get something from the internet, we would remove anything which doesn't point to our repository. Later, we would add our repositories. And we also here apply the SM build, which is the standard convention plugin. And we would apply also the bootstrap plugin from there. So going back. Our enterprise convention plugin sets the project repositories and automatically stages any detected publications for publishing. So typically our idea is that if you declare publication in some way, probably you want it published. So we removed the step which you have to assign it explicitly. It's a bit magical, but not too magical. It kind of matches the expectations. And these are applied for every build, and they don't provide any executable logic. It's just like things which are configuring tasks if you add them manually. Few things you may want to steal. Bootstrapping the build environment, the version is specified as project property. Repositories are always set by ID, and the Artifactory is set up as build environment. So the project can request that it uses certain repository. Typically they are defaulted, but you can put it in the project properties and by ID. All declared publications are automatically published, and we also add a number of plugins to the class path directly, so people won't have to have the build script in the projects, and we can version them as part of the environment. Conventions, so we configure common tasks, and we assert various things. I'm going to skip this one, and I showed some things from it anyway. So a few interesting stories. So we thought that we would collaborate like this. Alice at SMBC Nikko would request a change from Mallory, working for vendor. Then Mallory would push a snapshot. Alice would pick the snapshot and find a bug. Alice would request a fix on the change. Mallory would put a fix on the change and would push another snapshot, and Alice would pick up the snapshot and file a bug and would request a fix on the bug, and Mallory would put another fix, and so on and so forth, until Alice would pick up the change and find the bug, but it would be there would be a workaround so they can close the ticket. And it's not how it worked though. What happened is that Alice requested the change from Mallory, and meanwhile though, Bob would run a build, and Bob's build would pass. Mallory would publish a snapshot in response to Alice. Bob would code something simple and rerun the build. It would fail. Then Bob would ask Carol, because Carol is sitting next to him, to run the build on her machine as a sanity check. But her change in modules cache would not be expired yet, so it would pass. Bob spends half an hour debugging for how exactly his 5-line change managed to break the build. It's bad. And what can we do about it? Turns out that snapshots are a good fit only when everybody knows what's going on, which is pretty much when you're working alone. And then we have integration strategies. We thought of many actually. First is snapshots, which can change anytime without warning, and Artifactory can help, because if you remember to check Artifactory and diff the failing build and the successful build, you'll see that the changes actually that something changed. Then Gradle.com, the scans that we hear about, it holds some promise, but it's not on premises. So that's why the enterprise actually would solve this, but it was just announced yesterday. And we thought about semantic version. And semantic version, it can kind of help, but it adds overhead both to the provider and the consumer. In particular, when you're publishing something, you need to know whether it's backwards compatible. You need to know whether it's only bug fixes or you broke something. And very often people don't know that. They just didn't anticipate it. So it's more like the version is revealing the intent, not the actual guarantee. The other one, which is even less accounted for, is that you have change approval boards. And the change approval boards are not made of developers. They're made usually of business people. And when they see like sudden and weird version jump, and you explain to them that that doesn't mean anything, and they find it difficult to accept. So we tried the nightly versions, and nightly versions can actually work. And basically, the way it works is that there is a nightly build for everything. We depend always on the latest version. You may have some wildcard or whatever. And if the nightly build is broken, somebody kicks a build intraday. Things can still be broken, but at least they will be broken for everybody, and you won't spend the time chasing wild geese. And also we found composite builds. Ours are not really composite builds, we're just doing project substitution, but they're close enough, they're realizing the benefit. So we just get all the repositories, we hook them together, and we work from source. One of the big benefits is that you control when you pick the new code. You can also revert some code. You can revert even only one repository. You can do anything you want, really. It's very visible, very transparent. The next story is about the wrapper. Is it? Yeah, you can probably see it. It's git clone something. When you clone something, then you get something. Everybody's done it, then you change and you do Gradle Wrapper build, and then it does something like download, and then it shows a lot of dot, 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 dot. But sometimes it breaks. And the reason it breaks is because compliance doesn't like us loading stuff from the internet. So typically people in corporate environments cannot download stuff from the internet. That's why they have internal wrapper. But the Gradle Wrapper download URL is checked in. So if you're sharing code with a vendor, the wrapper works either for you or for them. And this leaves us with a couple of options. You can decide not to check in the wrapper, so everybody generates the wrapper every time, which is a bit annoying, and also it wouldn't point to your internal repository unless you do something like very long command line magic invocation. And yeah, you can see the things on the screen. It's basically messed up. So what can we do about it? Well, what we did is this. You have the real project, and then you have a project right next to it, which is a workaround for the wrapper. In this project, in the wrapper properties, you point to your internal repository, and then in the settings, you just include flat the project right next to it. It works, it's ugly. It could have been solved if only the wrapper considered like the Gradle.properties, but for some reason it's not. It's interesting that the wrapper has extensibility mechanism, and apparently the wrapper picks the properties which match the name of the wrapper jar. So we could have had, for example, a wrapper, and then a wrapper SMBC Nikko next to it, with a wrapper jar SMBC Nikko and wrapper properties SMBC Nikko. But if this company is building software that they're selling to 20 clients, this means they'll have 20 wrappers in the root, and not pretty. So we decided against it. That's our workaround, basically. And next thing is the feature branches thingy. I've talked with some people to get an idea what people are doing. Apparently that's a common problem. Imagine you have a repository. Is it visible? Yes. And in the repository you will have a branch, and the branch will be called master. And the built-in master will depend on some other repository. So the first repository is application, the second repository is library, and as things would happen, it would depend on the code which is in the master branch of the library. And the version will be 0.5 snapshot, right? It's defined in version.text, as many projects do. Now, one day you decide, many people are doing feature branching, and everybody says feature branching is good. So let's do feature branching. So you branch master into ABC123, matching your Jira ticket. And it also depends on the master, even though it's a branch, it depends on the master of my library, because you just copied it, and you copied also the dependency. But then you do your changes, and you realize you need to change the library. And until now, because you always worked on the master, you just changed the library. But now you know that you're on feature branch, so you branch the library, right? And in your local copy, in your local IntelliJ project, everything looks good, everything compiles, you did your change. And the problem is that when this ABC123 library publishes, it would publish to 0.5 snapshot. But it would be different from the master. And when the master publishes, it would also publish to 0.5 snapshot. Then that would lead to some people's builds breaking every once in a while on the continuous integration, and you don't want to do that. What Internet recommends is to include the branch as part of the version, right? Like this. So now the branch would depend on 0.5 ABC123 snapshot, and the branch would publish 0.5 ABC123 snapshot, and that kind of works, but it has some drawbacks. The problem is that it breaks if you try to use version changes. Anything with qualifier version is bigger than anything without qualifier to begin with. It's more ugly that you have to change the dependency version when you create a branch in another repository. So when we create the branch in the library, we needed to update the branch in our application, the version in our application, not only the text file in the library. And finally, the ugliest thing is that when you merge back to master, you need to remember not to merge dependency on a feature branch. And that's really, if you do it, nobody is going to notify you. The build is not going to fail. The build will continue. You just, at some point, you would realize that the master doesn't even compile, and our dependencies are still being resolved. What's going on? And then you would realize that you're depending on a branch. And it may be too late. Another thing you can do is you can choose not to publish feature branch artifacts. Then the continuous integration would work until the change starts spanning repositories. You can say everything should be really, any change should be closed in the right order, and you should make shorter lived feature branches, but they're not feature branches anymore in that case. You just have to integrate very kind of branch and merge all the time. You can choose not to continuously integrate feature branches. That's what we're doing actually. And proper fix would probably require change in the Gradle dependency resolver in some way. And Gradle actually already has that, almost has that, in the face of the Ivy dependency resolver, but we're using Maven descriptors right now. So with the Ivy dependency resolver, if you had Ivy metadata, and if the Ivy metadata had the branch property set, then you would be able to do like first resolve dependency with a branch, here is the branch stuff, and then resolve the dependencies without a branch. And then from the branch, you would publish to the branch thing. Oops, what time is it? I have to be gone. So we don't have time for the bonus track, but it was interesting, but probably you can read it on your own. So questions, probably we can take one or two. No questions? Well, you can always find me outside. Thank you very much.
Thank you.